So this video is about central angles and arcs, and we're talking about inside of a circle in this lesson. So let's start by defining a circle. Circle is the set of all points equidistant from a given point, which is called the center of the circle. And you name a circle by its center. So the circle in this picture would be called circle P. There's two more definitions underneath the circle. A radius is a segment that has one endpoint at the center and the other on the circle. So like in this picture, a radius would be PC. There's also two more radii drawn, PB and PA. So any segment that goes from the center to the outside of the circle is called a radius of that circle. And they're all the same length because that's the definition of a circle. Like the radius would be the same length all the way around. A diameter is a segment that has both endpoints on the circle, like AB in this picture, and it has to go right through the center in order to be considered a diameter. So this circle P has one diameter drawn, and that's AB. A central angle is an angle whose vertex is the center of the circle. For example, angle PAQ would be called a central angle because the center of that angle is the center of the circle. So the vertex of the angle is the center of the circle. PAQ is an example of an acute one. We could also have a obtuse one. That would be like angle SPQ. No, SAQ, sorry. And you can actually have a central angle that's more than 180 degrees. That would be something like this angle, angle RAQ. And an angle that is more than 180 degrees is called a reflex angle. Just in case you hear that vocabulary word. So we know acute angles are less than 90, right angles are 90, obtuse angles are more than 90, but only up to 180. Once you pass 180, it's called a reflex angle. And an exactly 180 degree angle, I guess I skipped over this one, would be something like RAP on this picture. Exactly 180 degrees is called a straight angle. So now we have more classifications for angles because when you're in a circle, you can go beyond 180 degrees. Now we need to talk about what an arc is. An arc is a part of a circle, and when I say that, I mean a part of the actual outside of the circle, a part of the circumference. A semicircle is exactly half of the circumference. So in the first picture shown down here, in the first circle P, if I were to connect T to S going along the circumference of the circle, that's an arc, and specifically it's called a semicircle because it's exactly half of the circumference. I would call that one arc, TRS, to show that I'm starting from T, going through R on the outside of the circle and then coming back to S. And notice the symbol I put over it is a curve rather than a segment because it's a curved arc. A minor arc, the second definition up there, is any arc that's smaller than half the circle, smaller than a semicircle. And that would be like in this circle, arc RS. And notice now I only need two letters. So to name a minor arc, you only need two letters. To name a semicircle, you may want to use three. Two would be sufficient also, but if I only talked about TS in this circle, back to the first one, that would be talking about, let me change colors, this semicircle, right? Okay, and then the third definition up here is a major arc, and that's an arc that's greater than half of the circle, so greater than a semicircle, and that would be like this, starting from R, going through this T, and ending at S, and so we would need three letters to name that, because if I only said RS, I would be going the shortest distance from R to S, and that would be a minor arc, so we want to use two letters for I guess I should say 2 points, because that's really what these letters are. 2 points when you name a minor arc. You want to use 3 points when you name a major arc. For a semicircle, you could use either 3 or 2. Just depends on how specific you need to be based on the picture shown. An arc is measured in degrees. It's got the same measure as the corresponding central angle. So on this picture, you can see the arc RT, which is out here on the circumference of the circle, is going to be a 50-degree arc because the central angle at S is 50 degrees. Of course, that makes sense. They look like both 50 degrees. The way we would write that is the measure of arc RT is equal to 50 degrees. And why is the measure of arc RT 50 degrees? Well, because the measure of angle RST is equal to 50 degrees, which you don't necessarily need to write, but you do need to know that the measure of arc RT is written like that, and it's a degree measurement, equivalent to the central angle. Now we're switching gears to talk about circumference, which is not an angle measurement, it's actually a length measurement. of basically the perimeter of the circle. So this will change depending on what your radius is, because if you have a small circle, the radius is only 2 centimeters, then the length around the circle is not that big. If you have a large circle with a radius of something like 8 kilometers, that's got a huge circumference. So it's depending on the size of the radius. The circumference formula, there's 2 versions of it. It's basically double the radius times pi. And since we know double the radius is the diameter, we could use the formula pi d, or you could think about it as 2 pi r, because 2 times r, that's our double radius, and then of course multiply by pi. An arc length, so now we're talking about the length of the arc, like in this picture AB, which is not the same as the measure of the arc. Measures of an arc are degrees. The length of an arc actually depends on how big your circle is, so it's going to depend on the radius. It's just a fraction of the circle's entire circumference. So the question is, what fraction? So you're basically doing the entire circumference and then multiplying it by a fraction that is going to be the degrees of AB, like the arc measure, over 360, because that would be the full circle. So you're going to take the circumference and multiply it by the ratio of the arc you want to find over 360. So let's say, for example, that this was, actually I think we have an example on the next slide. Let's change and we'll practice putting this formula into action. Okay, we have 2 examples, great. We have circle O on the left, in example A, is asking us to find the length of the arc shown in red. You can't tell which part of it is red, I'll make it a little darker here. This part here, so arc XY. To find the length of that arc, I'm going to start by getting the circumference of the entire circle. So circumference of the circle is going to be pi times the diameter. The diameter here is 16, so the circumference is 16 pi. I'm going to leave it in terms of pi. This is actually a number 16 times 3.14 approximately, so about 48 inch circumference. But we'll leave it in terms of pi. To get the arc length, which we typically call S for some reason, that's just the variable that we assign arc length, we're going to take the entire circumference of the circle, 16 pi, and multiply it by a ratio of the arc measure for xy, which is 90 degrees. I can tell that because the central angle is 90 degrees, therefore I know the arc length, the arc measure must be 90 degrees, and it's going to be 90 over 360. Now 90 over 360 reduces to 1/4, so this should make good sense. What we're doing here is taking the entire circumference of the circle and getting 1/4 of it. Because if you look at the circle up above, xy, the arc we're trying to find, is exactly 1/4 of the circumference. So you end up just multiplying 16 pi times 1/4. We can cross simplify to make our lives a little easier, and then we just have 4 times pi times 1, so 4 pi. The units on this are going to be the same as the units on your radius, because it's a length measurement, and just like your radius is a length measurement. So if the radius or the diameter is measured in inches, the length of our arc is measured in inches, and we'll just leave our answer in terms of pi. So 4 pi inches. In the second circle, we're finding, let me show you what part of the circle is red here. They want us to find this arc, which is a major arc, and they want to see if the length of it. So we know that the measure of that arc is 240. The length of it is going to be based on circumference. We'll start by finding pi times the diameter. Since the radius is 15, that means our diameter is 30. So that means the circumference of the entire circle is 30 pi. For the length of the arc that we want to find, which is major arc XPY, XPY, that's the arc we're trying to find. We want to do the circumference of the entire circle multiplied by the ratio 240 over 360. That's the fraction of the circle that we're trying to find. To simplify 240 over 360, that's going to go nicely. Imagine crossing out those zeros. 24 over 36 is just 2 over 3. So we end up doing 30 pi times 2/3. I can cross simplify, make this a 10 and a 1. And then it's going to end up just being 10 times pi times 2, which is 20 pi, and the units will be the same as whatever the radius units were, so centimeters. That's how you calculate the length of an arc. Not to be confused with the measure of an arc, so make sure you remember measures of an arc are degrees, length of an arc is going to be the same units as whatever the radius is measured in. And that is all.